Hi everyone, let's talk about the divisibility rule for division by 9. What most people will tell you is that 9 divides an integer n, a positive integer n, if and only if 9 divides the sum of the digits of n in base 10. And this is true, but there's more. This is part of a more general result, and the way we're going to discover it is through the proof of the original fact. So in base 10, what we can write n as is as the base 10 expansion, which is n equals to am 10 to the m plus am minus 1 10 to the m minus 1 all the way through to a1 10 plus a naught. And now the thing to notice is that, let me write up here for a second, is that 10 to the k is congruent to 1 mod 9. So we're using modular arithmetic here for all k greater than or equal to 0 integers. So what that allows us to do is get pretty close to annihilating all these powers of 10. They're all going to become 1. So this is congruent to am plus am minus 1 plus all the way through to a1 plus a naught mod 9. So that proves that if dn is equal to the sum of the digits of n in base 10, then what we get is that n is congruent to dn mod 9. So you can see how this implies the original result over here, because n is congruent to 0 if and only if dn is congruent to 0 mod 9. This one's also mod 9. So this result over here is more general than this result down here. Now let's do two more things. One is, let's talk about mod 3. Because 3 divides 9, that implies that n is also congruent to d of n mod 3. And that's just a basic implication using modular arithmetic, because 3 divides 9. So this is yet another result. And the last thing I want to do is show you an example of using this result. So let's say we have the number n is equal to 1, 2, 3, 3, and we're not wondering whether 9 divides it. So d of n is equal to 1 plus 2 plus 3 plus 3, so that's equal to 9, and 9 divides 9, so we know that 9 divides 1, 2, 3, 3. We don't know what the quotient is because we'd have to do long division to determine that, but at least we know that 9 does divide it exactly. Thanks for watching, and I'll see you next time.